Hello, PreCal. Today we're going to be talking about polar coordinates. And so let's begin. So, polar coordinates, I'm not going to read this little excerpt right here. If you want to, you can pause the video and read it yourself. I'm just going to highlight what's really important. So, what we do is in a rectangular coordinate plane, we use right angles to define where a point is, right? So, back in somewhere like Algebra 1, you were given something like this, and what this tells you is that if we go to the right 1 and up 2, this point lives at 1 comma 2, and this is the way that you've up to this point thought about graphing. Now you don't have to graph this way. We can also graph on a circular coordinate system, and a circular coordinate system, what's important to realize is that we base it off of r and theta. So for example, this point A, if we look, what we can notice is that we go out 1, 2, 3 concentric circles out, and that means that r would be 3, would have a distance of 3 units or 3, and we can look here and see that this is at 30 degrees, so theta would be 30 degrees. So the way we would write this is 3 comma 30 degrees. Now, we don't have to just write it in terms of degrees. And in fact, according to these notes, or maybe some other notes I just read, these points are commonly in radians. So this is actually 3 comma pi over 6. So earlier this year, you figured out how to convert degrees into radians. But just as a quick rehash, the way I always like to think of it is you have degrees and you have radians. And so what we know is that a circle has 360 degrees, but we also know a circle has 2 pi radians. So it's a proportion. So if I was to solve this particular problem, I would say the degrees are 30 degrees. I'm looking for the radians, which I like to call r, and the other side is the ratio is 360 to 2 pi. So you would cross multiply, and you'd get 30 times 2 pi equals 360r. I would then choose to divide through by 360, and that would eliminate the 360 here, and here I would just say, well, the 0 and the 0 cancel out. The 3 goes into 36 12 times, and 2 goes into 12 6, and voila, r is pi over 6. And this would represent this pi over 6. So you can always use this as a conversion tool, or you can always refer back to your unit circle. So I'm not going to stress, I'm not going to go over this in detail for every single one, but I wanted to remind you because it's been really almost this entire semester since you've seen this. Okay. All right, so let's look at these other points and figure out how we could find them. So B, we look, B goes out 1, 2 concentric circles. So this would be the equivalent of saying 2, there we go, 2 comma, now this is on 180, 2 comma 180, or if you prefer, 2 comma pi. Okay, if we look at the next point that they give us, that's going to be out what? 1, 2, 3, 4, 5 concentric circles. So this would be 5 comma 225, or if you prefer 5 comma, what is that, 225? That's going to be 5 pi over 4. Okay, and last but not least, we have point, and I know these are kind of hard to see. We have point D, which is here. It looks like it goes out 1.5. So this is, we're going to just say that this is just 1.5. So 1.5, and that's like at 300. So 1.5 300, or 1.5 comma 300, which is 5 pi over 3. And there we have it. So in these notes here, they're specifically just asking you for the degrees and radians representation. I went ahead in each of these and gave you both the radians and the radius and the degrees. So that's essentially what polar is about. Now, things get a little spicier because, as you can see here in the notes, it says in the rectangular system, every point has one and only one representation, okay? But in a polar, you have an infinite way of representing values, okay? So let's talk about why you would have an infinite number of ways. So if I was to graph 4 and comma 60 degrees, so let's see. Let me see if I can. There we go. There's one circle. I'm totally not doing this for everything. There's 2. This doesn't have to be perfect. There's 3. And here's 4. Okay, whatever. It doesn't have to be perfect. I'm not concerned with being exact here. So 4 comma 60 means I'm going to go out 1. Ooh. 1, 2, 3, 4. Actually, I'm thinking 30 there. Let's do that again. Sorry about this. 3, 4. Okay. So 60 would, oh, this really wants me to move the circle. 60 would be something like this. Okay. So we have 4 concentric circles out, and we'll say that this is 60 degrees right here. So this is 4 comma 60. There are other ways of writing this. Okay. And what you could do is, for example, when you spin something on a circle, you can spin as many times as you want, right? So if I want to go back to this point, I could spin it around 360 degrees. So instead of 4 and 360, I could just say 4 and 60 plus 360, right? Which is the same thing as what? 4 comma, was that 420, 4 comma 420 degrees. Okay, this is in degrees, so I'll keep it in degrees, right? So you could definitely add 360 to it, right? And look what those notes say. R can be R comma theta plus or minus 360n, right? So I could add more than 360. I could add 720. We could subtract 360, right? That would be another value that exists. So that's one way that we can play with this, and this is what these notes are saying. And I'll go more into this in a sec here. By the way, 360 and 2 pi are synonyms, right? So you could also do it with 2 pi if it was in radians. Okay, so we got that, but we can do something else here. What the other way that we could think about it is if this value was on the other side, right? And being on the other side would mean how many degrees across? Well, if it's straight across, this would be this distance that the blue would travel. Let's see here. This distance that the blue would travel would be 180 plus the original position, which is 60, because it's half the circle. Okay. So if that's the case, this is going to be at 240. So what we can do is if we say negative 4 240, well, this point is 4 240. But if I say negative 4 and 240, that is actually in the same position. Okay, so if you move 180 degrees away from the initial point and you negate the radius, because what that negation of the radius does is takes this radius and says, hey, we're going to go right back to here. Okay, so it kind of almost picks, I wish I could have some sort of animation here, but it picks this up and it puts it as the red line. Okay, so you could also negate the actual 4, right? And you would get that as well. And that would be the correct answer. Okay. So when we look back at our notes, what we can see here now is exactly just that. You can make R negative and add or subtract 360 or pi to theta, and it would generate the same thing. So you could, well, this is kind of written in a weird way. Basically, look at this. You can say, you can add, subtract 180 or actually 360 to it. And 360n just means that you can, like, as long as you're spinning on the circle, you're okay. Okay. And I give an example, right? 30, 30 plus 180. Looks like they did, yeah, 30 plus 180 is 210. And then they converted it into radians, okay? And that's the other thing. You could use 2 pi. 2 pi and 360 are the same. So that's the game that we're playing today. And so let's take a look at another problem here. So what I like to do, we don't have, if they give you a diagram with concentric circles, go ahead and do that. But it's kind of tedious for me to do that here. I like to do this. I like to say, well, we know, I'm going to say this distance is 5. Okay, this distance is 5 out. And just assume that you have 5 concentric circles. I'm not going to draw them out because that takes too much time. This is where 5, 315 is, right? And so if we have the negation of this, that means it goes on the other side, right? So it's actually over here. So if I subtract 180 from 5, this would give me where negative 5 and 315 is. So negative 5, 315 is here, right? But if I just simply subtract 180, it will tell me exactly where that is. Okay, so this is going to be 3, this is 2, so 135. So what I'm saying here, and so hopefully this is clear, this is also, while it's negative 5, 315, I can also say it's just 5, 135. Okay, so let's make sure that that's clear here. So because it's the negation, here's 5 and 315, right? If it's the negation, it's 180 degrees away, which would mean that if I subtract 180, I'm right back here. In other words, this angle right here is 135 degrees. And all I have to do now is consider it the positive version, and I'm good to go. So I'm good to go. But if they ask you to represent it other ways, well, there are tons of other ways you could do. You could add 180 to 315. I could take 315 and I could add 180, and this would give me 495. So I could also say it's 5, 495, right? And that would mean the same thing. And you could start at 135 and you could subtract 360, and that would work as well. Okay? So lots of different ways to do that. You could even add or subtract 360 from 315, and as long as 5 is negative, that would be legit as well. Okay? I'm not going to write out every single possible way. I just gave you a couple of different ways of looking at it. Okay? So I hope that makes sense. Let's move on to the next one. So 2, negative 90. Again, I think what's beneficial here is to look at a picture. So I'm always going to draw a picture, a diagram to kind of illustrate it. We're negative 90, so that means instead of going this way, we go clockwise instead of going counter. We usually go counter. We're gonna go this way. We're gonna go clockwise, and let's see what we get. So if I go clockwise 90 degrees, I'm right here. This is 2, negative 90. So again, if you want other ways of representing this, you could just, again, add or subtract 360 from 90. I'm going to use the fact that if I took this point, which is 290, right, 2, 90, if I negate the 2, I'm down here. So this is negative 2, negative 90. But we can also just simply say that this is also just 2, 270, right? This is pretty apparent, I think. If we spun it around this way, it's 2 out and a degree of 270. So just showing you 2 different ways. I'm not going to stress. There's a lot of different other ways we could say this. I've kind of exploited that a little bit more in the previous example. So 1, let's go on to the next one. 1, 5 pi over 6. This is the same thing as the degrees, only it's in radians. One day I'll figure out why it sometimes lets me draw straight lines and sometimes it doesn't. Okay. So we know that 5 pi over 6, and I think I kind of made that a little too high. Let's say that 5 pi over 6 is here. Say this distance is 1, So this is 1 comma 5 pi over 6. So lots of different ways of doing this. One way would be to negate the 1 and add. Now 180 degrees is just pi, so I'm adding pi. But pi is just what? Pi is just 6 pi over 6. So this now gives me negative 1 comma 7 pi over 6. And that would be a way of representing this. I'm sorry, not negative. This would be, no, that is, if I could add, that would be correct. 5 plus 6 is not 7, it's 11. I don't know why I did that. It's like something doesn't seem right. 11 pi over 6. So this negative 1 comma 11 pi over 6 would be a value. Apologize for that. All right. So essentially what I'm saying, just to be clear, I'm saying if this point right here is 1 comma 11 pi over 6, right? So if I negate this 1, I'm now over here. Okay. So there's one way. And then you could simply also just add or subtract 2 pi from 5 pi over 6. So I'm just going to say 1 and 5 pi over 6. I'm just going to add 2 pi or 12 pi over 6 because 12 divided by 6 is 2. So this will give me 1 and 17 pi over 6. And that would be another value for this right here. Okay. All right. Let's look at this one. So if I draw this out, so now we have negative 8 and pi over 6. So first thing I'm going to do is I'm going to go, if I did 8 pi over 6, it's here, right? But we're doing negative, so the negative would be 180. I tend to think in degrees, but also pi, right? So if I add pi, I'm at negative 8. Add pi to pi over 6. Now, keep in mind we have 6 in the denominator, so I'm going to go ahead, instead of adding pi, I'm going to add 6 pi over 6. So I can call this negative 8 and comma 7 pi over 6. And then what else? What else? I'm sorry. This would be 8 positive 8 and 7 pi over 6. This is also negative 8 pi over 6. So let me be clear here. I feel like I'm kind of botching this up a little bit. This is at negative 8 pi over 6. So if I add pi or pi to pi over 6, I get the positive version of it. Sorry about that. Hopefully that's clear. And then, again, if I want more values, I can add 2 pi to 7 pi over 6 or subtract 2 pi. Let's go ahead this time. Let's subtract because we've been adding. So we're going to have 8. I'm going to take 7 pi over 6, and I'm just going to subtract 2 pi or 12 pi over 6. So this will give me 8 comma negative 5 pi over 6. And this would be another value. That's legit as well. Okay? And notice you can play with this. You can do this in a lot of different ways. If I subtracted here just to create diversity, but I could have added. There's a lot of different ways we could play this. Okay? Let's look at this one. This one's nice. It's both of them are negative. So we know that when we do 5 pi over 3, if it's negated, we're going to go spin this way. And it would actually be in the same place that pi over 3, let me actually erase this, because otherwise it'll get cluttered. It's the same exact place that pi over 3 would be at. So this is negative 3 over 2. Well, this would be positive 3 over 2, 5 pi over 3, right? Negative 5 pi over 3. So what we could do, now you can leave it like this, but I think it's just easier. Let's just take that out and let's think of this as pi over 3 because they are equivalent. Okay. In fact, if you wanted to in the beginning, you could have just added 2 pi So you don't have to worry about that, and that would end up giving you pi over 3. Okay, so if you want to, you can just jump straight there. And then, because this thing is negative, right? This one's positive, right? But if I make it negative, that means I have to jump 180. So you're going to add 180 to this. So you're going to add 180 or pi or 3 pi over 3, and that'll give me 4 pi over 3, which now puts you over here. So this is the equivalent of negative 3 over 2, negative 5 pi over 3. This is where this lives, but this is also the same thing as 3 over 2, comma, 4 pi over 3. Okay, so there's 2. If we wanted one more, again, add 2 pi, subtract 2 pi. I like the positive, so I'm just going to go ahead and add 2 pi. So this is 3 over 2. Well, actually, why don't we just do this? If we just say negative 3 pi over 2, and then we calculate this to be pi over 3, we can just drop pi over 3. And that would be the same thing. So we actually already, from here, we actually solved another one. There you go. So hopefully that makes sense. It's not too confusing. This is how polars kind of work. As you continue to play with it, you'll find this to be easier and easier to work with. But if you guys have questions, comments, please reach out to me, and I will definitely help you guys out. So that's it, and I'll see you in the next math video. Goodbye.